In this demo, we will learn how to use HTTP request message directly to send our requests. By writing getAsync, internally an HTTP request message with HTTP method get will be created. It will also use the default settings as set on the HTTP client we're using. So that's what we did in the previous demos. And while that's great if you always need the same settings, it's not that great for the scenario we just detailed. If you think about it, an accept header, that's a property of a request and not of HTTP client per se. We can create such a request message ourselves. So let's add a new method to our CRUD sample service. Get resource through HTTP request message async. And let's use our factory to create a new client instance to work with. Up next, we create a new HTTP request message. We pass through get as the method and API/movies as the address of the resource. Then we add a new media type with quality header value with application JSON as the type to the accept collection on the request's header property. Any default request message header set on HTTP client will now be ignored for this request. To send such a request, we have to use sendAsync instead of getAsync. GetAsync, as we previously used, is just a shortcut for a request message with HTTP method get. But if we manually create our request message, we can create it with any HTTP method we want. Therefore, sendAsync. The rest of the implementation is like we previously wrote. We ensure a successful status code, read out the content and deserialize using system.text.json as we're only accepting application JSON. Let's set a breakpoint here. And let's make sure we call this method when we run the application. That should do it. Let's give this a try. We hit our breakpoint, and we indeed got back our movies. But there's more. We still have some default values for HTTP client that are used across requests. The base address and the timeout values. Those are set in both our methods. So this is duplicate code. We can get rid of that. Let's check that out next. In this demo, you will learn how to provide default values for HTTP client and system.text.json. There's a lot you can do when configuring HTTP clients. We will learn much more about that in the module on the HTTP client factory. But one of those things is providing default values. We're looking at a program class where we called into add HTTP client. Let's add an action to configure that client. For that, we have to pass through a name for our client. Movies API client sounds like a good name. And we pass through an action to configure the defaults. Through this action, we can now set common configuration values like the base address, timeout, default headers, and so on. All the things we looked into before. I'll set the base address and timeout values as those are the two we're currently using. The best practice here is to use configuration at this level for properties that remain the same across requests. For other configuration-related items, use HTTP request message directly. So, if your requirement is to use application JSON everywhere, you could set the accept header value here via configure client, .default request headers, .add, and so on. A few years ago, that was a pretty common use case. These days, APIs tend to be more strict in their use of media types. They go for vendor-specific media types that say something about the actual type that's being returned instead of just the format. I detailed that approach in my ASP.NET Core Web API Deep Dive course. So, for our demos, we will not add it at this level. Alright, let's switch back to our CRUD samples class. To create a client, we now pass through the name we gave it when configuring it. Movies API client. We do that in both methods and we can get rid of setting the defaults here. There we go. Let's give this a try. I'll again set a breakpoint here. We hit our breakpoint and our request was successful. Alright, then let's have a look at that other repeated piece of code. Newing up JSON serializer options and passing them through on each request. That's duplicate code, and I don't like that. What I would prefer is to be able to globally change the defaults, so we don't have to pass through a JSON serializer options object. But the .NET team decided against allowing that. There is a very lengthy discussion over on GitHub in regards to this. In this you can read about the reasoning behind their decision if you're interested in that. For us, it's important to know that it cannot be done, so we will have to work around that. What's also interesting to know is that it is possible to new up a JSON serializer options object with the default settings for ASP.NET Core Web Apps, like our API. You can read more about that via the link on screen. Well, this might be interesting, right? It already includes the option we're using. Property case name insensitive is set to true, and it adds two other ones in regards to the property naming policy and number handling that makes integrating with web apps easier. So what we want to do is find a way to create a global JSON serializer options object from these settings that we can reuse across our app. That is not too hard to do. Let's add a new folder, helpers. And let's add a JSON serializer options wrapper class to it. Let's clean this up a bit. There we go. We're going to use this class to expose the options with the settings we need. So we add an options property to our JSON serializer options wrapper class, and we new that one up in the JSON serializer options wrapper constructor. Then let's make sure we can inject this. For that, we want to register it on the container. We register it as a singleton. That ensures that only one instance will exist, which will be reused across requests. We don't expect these default options to change. Let's provide the necessary using statement to the helpers namespace. And there we go. From this moment on, we can inject it in our code wherever we want it, using constructor injection. So let's do that in our CRUD samples class. There we go, that takes care of that. And now we can use the options property on our JSON serializer options wrapper to pass through whenever we want to deserialize. So let's do that in both methods. That's one. And that's two. That's already a bit cleaner, right? Let's give this a try to make sure that it still works. We hit our breakpoint. And that indeed still works like a charm. One more thing. For the rest of the demos, let's set the default media type our API returns back to JSON. That is probably more realistic these days than XML. Let's continue with creating a resource. In this demo, we will send a request to create a resource. We'll keep on using HTTP request message directly for now, as it makes it easier to see what exactly we're setting and what's going on, as it mimics a request message. But if you prefer to use shortcuts, we will look into those at the end of the module. So let's add a method, and let's get a hold of a new Movies API client instance. Just as there is a getAsync method on HTTP client, there is also a postAsync method. As we know by now, this is a shortcut which behind the scenes creates an HTTP request message. We're not going to use the shortcut at this time. Instead, we will work with the request message directly for the reasons we just looked into. So, what we want to create is a new movie. So, let's first new one up. There we go, another great movie from the 90s. As we're not sending over the movie as a movie object, but as a serialized version of it, we then use the built-in JSON serializer to serialize it to a string. For that we call into serialize on the JSON serializer, passing through our movie to create object. Note that this will serialize with default settings, so with property names as they appear on the class itself. In other words, starting with an uppercase letter instead of with camel casing. Whether you want to do this or not depends on what the API you send this to is willing to accept. Our API can easily deal with regular casing and camel casing, so sending it like this isn't an issue. Yet, typically, you would expect JSON sent over the web to be camel cased. We can easily make sure that that is the case just by passing through the options we set up in the previous demo. They ensure that camel casing is used. Alright, then let's create our request message. This time it's a post to API/movies, which is the endpoint at API level to create one new movie. We also add an accept header, as post actions often return the newly created object in the response body. By setting the accept header, we're stating that we are willing to accept JSON in this case. On to the content. On the request message, there's a content property of type HTTP content. That is a base class we will look into immediately. For now, it's sufficient to know that string content derives from HTTP content and allows us to pass through a string. In our case, the serialized movie. So we set the content object to a new string content object, passing through our serialized movie to create string. In our case, that's application JSON. We can set that by passing it through via the string content constructor. That, again, is a shortcut for setting it directly on request.content.headers.content type. We're gonna go for the option that mimics the request message best, which means setting it directly on request.content.headers.content type. And the rest of the code should look very familiar. We call sendAsync passing through the request, and we ensure that we've got a successful response. If that is the case, we read out the content. Let's make sure we call our createResourceAsync method when we run the application. So far so good. Let's set a breakpoint at the end of the method here. And let's give this a try. We hit our breakpoint without hitting an exception, so this is looking good. Let's have a look at the created movie. And there we go. This works as expected. That was easy enough, right? Let's dive into some more detail on setting request headers and on that HTTP content object.